This question, right? So in this question was asked in IIT, right? So basically, uh, mains JEE mains entrance exam in 2023. Okay, so 2023 they asked this question, right? So the question is, the actual question is a thermodynamic system, right? A thermodynamic system is taken through a cyclic process that the total work done in the process is. So this is the question, right? So the question is the thermodynamic system is taken through a cyclic process. The total work done in the process is, right? So there is some thermodynamical system, right? So it performs the work in a cyclic manner. That means wherever the process starts, it will end at the same point. Wherever the initial point it started, after the complete cycle, it will reach to the same initial points, right? So that is a closed cycles, right? So closed loop, the process takes place in a kind of a closed loops. So during this complete cyclic process or one complete cyclic process, how much work done is happened, or how much work done is uh, uh, work is done in that complete cyclic process, right? So in one complete cycle, right, in this case basically, right, in this case basically it starts from here the point C and goes to the point D, then goes to the point E, then comes back to the point C. It reaches the initial point where it started. So it is a closed loop or closed cycles. So it's where it started, in the same point it will end. The initial and final point will be the same point, right? So that is the closed cyclic process, right? So in this cyclic process, it starts from here and goes here, come back here and come back here. So in this process, how much work is done, that we have to calculate, or how much, what is the total work done in this one complete cyclic process, what is the total work done, so that we have to calculate, right? So how we can calculate? So before going to the calculation, we will see, so what is the diagram and what are the parameter they have given. So x-axis is the volume, y-axis is the pressure, right? That is basically the PV diagram. So it's a PV diagram, right? Second thing is they have given some points. So what are the points? So basically this is the C point and this is the D point and it is the E point. So from this diagram we have to take the values, right, coordinates of these um, the cyclic process. The point C gives us the following, that is C is equal to, what is the x value, that is 2 meter cube. Then what is the y value, right? So y value is this, x value is this. I have written the x value. Now y value I have to write corresponding to the point C. So that is 100, right? So 100 Pascal, right? PA. So then we have to write the point D value. D is again, right? D is again, the value is, D is 2 meter cube, right? That is the volume, and correspondingly the pressure is 400, right? 400 Pascal. And similarly point E, right, this is the point E, so that coordinate we have to write. So coordinate E is equal to, right, what is the y value, sorry, x value is 4 here, therefore 4 meter cube, and corresponding y value is 100 Pascal, right, 100 Pascal. These are the coordinates now. That is a P from the PV diagram, which is already given in the problem statement. We got these the values, right? We got these values, basically the coordinates of the PV diagrams that is given for this cyclic process, right? So then what we will do, we basically to calculate the total work done. So in this cyclic process, to calculate the total work done, we have to calculate area under this triangle. So this is basically triangle. If I able to calculate the area under this triangle, that will give me the total work done in this closed process or cyclic process, right? In this thermodynamical process or cyclic process. So this is a PV diagram. This is a P, right? This is V, right? In this PV diagram, if I am able to calculate the area under this, I will be getting the total work done. So therefore now we will try to calculate the area under this triangle. So now to do that, what we will do, we will take the formula for the what is that, so area under the triangle, right? So area of the triangle, is we have to calculate, that is W is equal to, right? W is equal to of base times the height, HEIGHT. So this is the area of the triangle, right? So this will be the area of a triangle. So therefore what I will get is this. Okay. So now what we will do, now we will calculate the base. We have to calculate the base and then height, right? If you calculate base then height, then if you substitute in this formula, we will be calculating the area. So if the value whatever we get is then work done, right? So therefore now I will calculate the base. Base value is equal to, what is the base value here? So base value is, so this is the base, right? This is the base of our triangle. This is the base. So that means I have to calculate this distance. That is basically 4 minus 2. That is 4 minus 2 is equal to 2. So then I have to calculate the height, right? So I have to calculate the height. How much? This is height. This is the height. This height I have to calculate. So that is HEIGHT is equal to 400 minus 100, which is equal to 300, right? So that is my height. So now what I supposed to do is I have to substitute this value. This is in Pascal, this is in meter cube. So if I just substitute this value, right, basically what I will get, the total work done. So therefore my work done now, so W is equal to 1 by 2 times base value is 2 meter cube, that is 2 times height, right? So the height value is 300 Pascal, that is 300. So what I will get, if I simplify this, I will be getting this 2 will get cancelled, and then I will just have 300. It is joule, right? So therefore W is equal to 300 joules. So therefore the right answer here is 300 joules. That is C is the right answer, right? C is the right answer in this. C is the right answer. 300 joule is the right answer for this question, right? So this is how we have to approach this problem, right? So